Hello everyone. Today we'll be talking about machine learning in soccer analytics, how it is used, what are the various aspects and methods used for this particular use case, and how it has affected the way we understand the sport. We'll be going through the mentioned points in detail, starting off by introducing the topic. Next, we will describe the goal of this particular study, what we intend to achieve, the data which will help us achieve the goal. Moving on, we will go into detail how machine learning can be incorporated in the field of soccer, what models were used, what results did we achieve, and were the results impactful or not, and whether the results were in line with our expectations. Lastly, we will go through the conclusion for the project work and what is the future scope for machine learning for in soccer analytics. So let us begin. Sports analytics has revolutionized the world today. The basic idea here is to firstly collect huge chunks of data, preferably historic, and apply machine learning models and algorithms to uncover hidden trends and insights. Using these results, teams, individuals, and also coaches can effectively detect patterns and create robust strategies in order to gain a competitive advantage over their opponents. Talking specifically about soccer now, machine learning and data science methodologies can be used for aspects like tracking match events, predicting the outcome of a game, match performance evaluations, set piece optimization, player recruitment strategies, and game planning. Using data driven results, such analysis can be of great importance in contributing to the success of a team. The goal of this study is to extract unknown and hidden valuable insights by implementing various machine learning technologies over vast amounts of data, which is kind of historic. It attempts to identify patterns and trends in players as well as in teams in order to provide accurate and just information to fans across the world. Not only this, with the help of this study, teams, coaches, and possibly organizations can also benefit by implementing more effective strategies both on and off the field. Some questions that this study intends to offer include: what team dominates each of Europe's top 5 leagues? What is the past 10-year trend across Europe's big 5 leagues? Which team was most successful? What made it the most successful? And some defensive and offensive stat analysis. So let's talk about the data. Well, the first and the foremost step in implementing any machine learning method is to collect relevant data. Thankfully, soccer data is abundantly available on the internet. We made use of the website called FBref as it has extensive historic data with differentiations based on countries, clubs, players, competitions, etc. Adjoining is the snippet of the website. To make our study more targeted, we gathered the mentioned data from the website: table statistics, defensive and offensive statistics, possession stats, some squad play time, and some general country specific league statistics. It's not that simple that once we collect the data, we can simply implement a machine learning model onto it. Before a machine learning model can even be implemented onto a data, it needs to be pre-processed, cleaned, and put into the correct format. The image here shown, first of all, represents the raw data which was collected using API calls, and then the clean version of it, which can possibly use to implement various machine learning models. There are some attributes in our particular data set that might be new to users, so we thought about explaining some of them. For instance, the first one here is XG, which is expected goals to be scored by a team based on their performance across the season. XG plus minus 90 is the expected goals scored minus the expected goals allowed by a team while a particular player was on the field. Progressive carries is basically the movement towards the opponent's goal at least 10 yards from its further point in the last 6 passes. Attacking touches, touches made by a player in the attacking half or in the opponent's defensive half. And the venue, which venue is particular to a specific team, whether a particular team is playing in their home stadium or away. Let's talk about how machine learning can be used in soccer analytics. Well, this is what a generic machine learning lifecycle looks like. First of all, we have to define the problem that we're trying to solve. Next, there has to be relevant data available for that particular problem. We need to collect the data and prep it up. Thirdly, we have model engineering, which is deciding on what kind of model to be used and implemented. Step 4 and step 5 are kind of iterative, where basically we evaluate our model to check if the results are actually useful or not, and then further improve it for better accuracy and improved insights. Okay, so let's talk about the methods that our study will be focusing on. First of all, we have clustering. The word cluster literally means grouping of similar items together. Essentially, we have data points spread across, we have various data points spread across in our data set, and based on the similarity of numerous attributes, we intend to cluster them into specific clusters having same kinds of attributes together. Next, we have ARM, which is association rule mining. The method attempts to identify the items that are frequently purchased together and the degree of association between them based on various metrics like support, confidence, lift. Next, we have naive Bayes. Naive Bayes is a classification technique that works by calculating the probability of each class for a given set of features and then selecting the class with the highest probability as a predicted one. The main assumption for the naive Bayes classifier is that it assumes that the presence of a particular feature in a class is independent from any other feature being present in the class. Next, we have decision trees. Well, in simple terms, decision trees are basically if-else statements. The algorithm works by recursively partitioning the data into smaller subsets based on different kinds of input features that we provide it with, and it keeps on iterating itself until the final node becomes as homogeneous as possible with respect to the target variable. Talking about a little more complex methods. Firstly, we have support vector machines or SVMs. SVMs are again essentially used for classification purposes. The SVM algorithm works by identifying and finding a hyperplane, which is basically a division. You can think of it as a division line between the data points that acts as a separator between them. As shown in the left-hand side image, the SVM model attempts to maximize the margin between two data points so that if any of the new data points are fed into this particular model, it is effectively able to classify it into the correct class. And lastly, we have neural networks. The architecture of a neural network is modeled based on the behavior of a human brain. In simple terms, a neural network works by taking in input features from the data, learning about specific characteristics of the data which has been fed, and then returns an output. The process is iterated over and over again until we have minimum loss and good accuracy. Moving on to the results that we got from implementing the models discussed. Firstly, clustering. The first image here on the left hand side is a visualization which attempts to determine the optimal value of k, that is the number of clusters. The idea is to have clear and precise boundaries without any kind of overlapping. As can be seen, the value k is equal to 3 seems to be a good fit. Once the value of k is determined, on the right hand side we have the image for implementing k is equal to 3, wherein the squads that can be seen have been clubbed together based on having similarities across various attributes that the data contained. Next, we have association rule mining. We implemented the association rule mining using the a priori algorithm. The image here showcases the top 15 rules created by the algorithm, sorted according to the lift value. The ARM implementation was particularly helpful in identifying specific features and how they contribute towards detecting patterns. For example, we can see that over the years, the English team Brentford has been dominated by Danish players, and the English team Everton has had defenders which have been largely belonging to the UK. Qualifying for Europe's most prestigious league, that is the UEFA Champions League, is every team's goal throughout the season. So we made use of the naive Bayes implementation, and we were able to determine what kind of factors strongly affect the qualification of a team into the UCL. The predicted classes here can be explained. Class 3 is the ones having teams which were qualified onto the UCL, and Class 2 are the teams which were relegated from the respective league league competitions. The first image on the left hand side shows that having a good goal difference in turn results in securing more points, in turn leading to a higher league position and meaning qualification for the UCL. On the right hand side image, we can see that we do not have as good of a trend as we can see on the left hand side image. Nonetheless, we can infer that teams having conceded less and score more tend to qualify for the UCL. Talking about decision trees, we got to determine certain factors which hugely affected the overall performance of a game using this particular algorithm. Factors like expected goals scored on a recent form per 90 minutes, or how frequently a squad enters the final third of the opposition, or what kind of ball possession does the squad have. Is it offensive? Is it defensive? Did all contribute towards a team being successful. The output variable was converted to being either positive or negative, and then the decision trees was implemented to showcase what kind of factors are responsible for a positive or negative outcome. On the left hand side, the green colored nodes show a positive outcome, whereas the red ones show a negative outcome. The SVM algorithm was implemented to predict the outcomes of a soccer match based on historic data. Different parameters and implementations of the algorithm were used, and interesting facts were discovered. One of the results that we got, which were failed, wherein we could not see any kind of division being created by the SVM, was that the expected goals and the expected goals allowed were too complex to determine the boundary of our classification. Also, an interesting fact on the right hand side image, even though you can see the lower values for possession, that does not mean that a team cannot win a match. And finally, neural networks. Neural networks were again used to predict the outcome of a game. We implemented a simple network with 5 inputs, 2 hidden layers, and a single output, and it got an accuracy of 85% as shown on the left hand side image. As the neural network progressed, the loss reduced and the accuracy increased, which can be shown on the right hand side image, which is also known as the learning curve. Factors like venue, either home or away, number of rest days between games, and the competition in which the match was being played did affect the outcomes of a game. So finally, we can say that machine learning models have become increasingly popular in soccer analytics and providing data-driven approach to understanding the game. These models can be used to predict a number of things, from predicting outcomes of a match to identifying features which are important in determining the success of a game, in order to effectively predict whether a player can get injured or not, to create more robust team strategies, and more. Moreover, the use of machine learning models can lead to better decision making by coaches and team managers, and it can also lead to improved performance on the field. Overall, machine learning models have the potential to revolutionize the way soccer is played, analyzed, and understood by fans and all other people across the world. I wanted to talk about the future work as well because there's a huge amount of scope for this particular field and machine learning being implemented onto it. For example, instead of just using basic player statistics, with the advancement of technologies and the thousands of sensors that we have, a lot of more kinds of data can be generated, analyzed, and new kinds of trends can be implemented. Some of the metrics, such as live win probability, live threat, could also be incorporated in future studies. Another area for future work could be in developing more sophisticated models that can account for contextual factors such as weather conditions, team morale, injuries, and whatnot. Thank you for having the patience to go through this video. I hope you enjoyed it. And in case you want to have a more detailed look onto what kind of models were implemented and the results, do visit the website mentioned here. Thank you.